Hello again, guys. Hopefully all's well with all of you. Hopefully all's well with me too. Today we're going to learn lesson 8.4, which is called Special Products. Lesson 8.4 is really an extension of the beginning of lesson 8.3. So we're going to tie back to the FOIL stuff that we were learning at the beginning of lesson 8.3. We're just going to do it over the three special cases that I'm going to outline today. Now these special cases are really important because when we turn this process back around in the last three lessons of the chapter, and we try to break these back apart in a process called factoring or division of polynomials, then we're going to be really looking for these three special case scenarios because they create a little bit of difference in the way they're processed versus the way that other polynomials will be factored. So we're going to see a little difference between what's going on with these three than what's going on with the main three. But today's lesson should go pretty smoothly because we're just going to be reiterating that FOIL process. It's really just an extension lesson for today of what we've already done. Okay? So hopefully everything is going to go okay. Again, if you need help with this, if we need extra help, I'll be available on Zoom and I'll be available over email during any chunk of time. So just let me know what you need from me if things aren't going well, and we'll take care of it. If you're following along, we're on page 515. We're going to go through these special three cases of special products. The first one is called a square of sums. Now it's very, very important that we understand that squaring a binomial like this, when we have a binomial, two terms, squared, it is not the same thing as taking something like 4x squared. If we were doing this, we would just square both components, and that would just be 16x squared. That is not what we are doing here. There are components of that here, but that's not what we're doing. You also cannot just square both parts of the binomial and say, well, I'm done. The answer is not x squared plus 16. It does not work that way. You have to go through the FOIL process here so that you have the correct answers when you're done. The way we're going to work a problem like this is to write it twice with a multiply in between, because that's essentially what it is. X plus 4 squared is x plus 4 times x plus 4. Now we can FOIL this out like we would have done otherwise. So our firsts, x times x, gives us x squared. Our outsides, x times 4, gives us 4x. Our insides, 4 times x, also gives us 4x. And our lasts, 4 times 4, gives us 16. Now you'll see that there are components of what we talked about if you just squared this out. However, just squaring those two pieces does not give us the solution that we need. Now, to clean this up, we can put these middle two pieces together because they are like terms. They are both x to the firsts. So I end up with x squared plus 8x plus 16. Now, there's a very important relationship in this solution that we need to identify. If you look at the original number here, compared to the two numbers that we got, the number in the middle, or the linear term, ends up being 2 times what we started with. The number at the end ends up being this number squared. That's a very important relationship that we need to continue forward, and then as we're watching for these in the future, we need to be watching for those components. Because if we're seeing that relationship, that means that we're dealing with a square of sums. Now this one is going to be a little unique because of this 2 out front. And it's very important that we look at more difficult situations like that so that we understand how to deal with it. Again, we're just going to FOIL this. Write it twice, 2x plus 7 times 2x plus 7. The process works the same. Firsts, 2x times 2x. Coefficient times coefficient, 4, x times x, x squared. Outers, 2x times 7. 2 times 7 is 14, x times no x is x. Inners, 7 times 2x. 7 times 2 is 14, x times no x is x, and then my last 7 times 7 is 49. Now this one is a little more unique in the fact that my leading coefficient has changed things slightly. 28x plus 49. 14x plus 14x is 28x. You'll notice the relationship between the start and the finish. 2x up here translates down to 4x squared there. The 7 here translates down to 49 there. But now what about this middle term? The way you find the middle term from the original, while we're watching for this in our sum of squares, is that it is these two terms multiplied together and then doubled. So we have the times 2 relationship here. The times 2 relationship will hold true here, except we need to multiply our terms together. Now, if you're not seeing that right now, that's okay. As we build further and further, we're going to see it more and more. And when we're dealing with these are the easier case ones to turn back around and factor. So it's very unlikely that it's going to become a major issue for you if you're not seeing that pattern in this. But we take 2x times 7, which is 14x, and then times it by 2 to get to our 28x down here. That gives us our square of sums. Now I'm going to walk over to my square of difference section, which is in the middle here. You'll notice that the only difference between this section here and this section here is that the binomial is separated by subtraction. So instead of being addition problems, they're now subtraction problems. We're going to split them the same way. X minus 8 times x minus 8. Go through our FOIL process. First, x times x is x squared. Outside, x times negative 8 is negative 8x. Inside, negative 8 times x is negative 8x. And my last is negative 8 times negative 8, which is 64. When we put these middle two terms together, we end up with x squared minus 16x plus 64. This is sloppy 4, sorry. You'll notice the only difference in this answer in the sum of square difference problem versus the square of sums problem is the middle term is now negative. The first and last term are still just the squares of the outside pieces. X squared. Negative 8, 64. And the middle term is still double that second number. Negative 8 times 2 is negative 16. The same relationship holds true here. It's just that we have a negative in the middle now. Let's work this one. X minus 2a times x minus 2a. Sorry, that was a sloppy. First, x times x is x squared. Now you'll notice that Mr. P put a variable in the second part of this one, which is possible, instead of putting a coefficient on the first term like I did on that one. It just changes the element just slightly, gives you another little look at a different way this could line up. Now we're going to come over here. Negative 2a times x will be negative 2ax. Make sure to keep them alphabetical. A before x. Again, in the middle here, negative 2a times x is negative 2ax. And then my lasts give me negative 2a times negative 2a, which is 4a squared. Again, we can put these middle terms together. This is a little trickier. They are the same. They're both ax's. So I have x squared minus 2 times 2, or 2 plus 2 is 4ax plus 4a squared. We need to watch very carefully that the pattern works the same in here as well. Now, the tricky thing for this particular problem is because 2 squared is 4 and 2 squared is, or 2 times 2 is also negative 4, they end up being the same number here and here. So that can get a little confusing for some people. But this one is the number squared, this one is the number doubled, times 2. Last case, difference of squares. Now you'll notice that these ones aren't pushed together like the first two were. This was x plus 4 squared, this was x minus 8 squared. These are the easiest to work with on this lesson, but they're the hardest to factor when we get to the next lesson. I'm going to show you why coming up here. When we multiply these out, we're going to FOIL, just like we've been foiling before. X times x is x squared. X times negative 4 is negative 4x. Insides, 4 times x is positive 4x. And my lasts give me 4 times negative 4, which is negative 16. Now, if you look at these middle two terms, when we bring those like terms together, I have negative 4 and 4, and that's going to give me 0. The middle terms are going to drop out of the answer. That's going to be true for all difference of squares problems. We only end up with 2 terms in our answer, which makes these easy to work with right now, but really difficult to notice later. Now the name here, difference of squares, comes in the answer, not in the front. These are both named by the way they look at the start. This is a sum of square, or a square of sums, meaning I am adding sum squared. I am subtracting difference squared. Over here, our difference of squares comes in the answer. I have 2 perfect squares, x squared and 16, and they are subtracted from each other, hence difference of squares. Let's FOIL out this last one. First, x times x is x squared. Outers, x times negative 9 is negative 9x. Inners. 9 times x is 9x. And my lasts, 9 times negative 9 is negative 81. Again, you will see on all these differences squares, when I add my middle two terms together, negative 9x plus 9x, they will become 0, which will cancel them out. So I end up with x squared minus 81 as my solution. Hopefully this goes okay for you guys. It's just an extension on foiling. Remember to check the notes on Schoology and also watch for extension videos on Mr. P doing additional problems and helping out. Okay? Your homework is on page 515. You're going to do 12 through 20 and 22 through 30. In the days to come, my plan is to hit pause at this point in time because we've covered the first half of the chapter. We're going to do the mid-chapter quiz as a quick review. Then we're going to do a worksheet on the first half of the chapter, which was a test but will now be a worksheet so that you can work through it on your own. And I will post a video discussing that coming up. So your objectives over the next couple of days, or over the next week really, is going to be to just really hammer down and get good at what we did in the first 4 lessons. We're adding and subtracting polynomials, multiplying monomial times binomial, monomial times trinomial, then we're multiplying binomial times binomial, binomial times trinomial, trinomial times trinomial, and now we're doing special products, which are all FOIL situations. Hopefully everybody has a good grasp of what's going on in these lessons. Again, if you don't, make sure to email me or let me know. Try to contact me during our designated Zoom times so that I can help you get back on track and we can move forward.